Okay, hello everyone, I'm Chan Young Kim, who is the team leader of BTS project Triple S, and today I'd like to have a brief presentation about the development of seismic performance assessment, considering AI models and aging of various civil structures. The presentation will follow the order as shown in here, and I'd like to start from the introduction. So the seismic fragility analysis of infrastructure is important techniques to maintain the safety of society and to prepare for future accidental cases. And in nowadays, the machine learning method has emerged in civil and structural engineering. Also, for the seismic fragility analysis, many researchers adopted the machine learning techniques for the seismic fragility analysis because it requires consideration on possible uncertainties. And also, it is important to considering about the possible degradation in the nuclear power plant structures. So, in this reason, this study is focused on the selection of machine learning methods which was appropriate for the seismic fragility analysis of steel frame moment structures, and also try to conduct the seismic fragility analysis considering Alcalá-Silca reaction model in the nuclear power plants. So the next chapter is about the development of machine learning methods, and we're using OpenSys version 3.3 for the analysis on steel moment frame building. The used element was summarized in this slide. And also we're considering about various structural parameters which was summarized in the right figure. For the input ground motions, we used the earthquake records from Miranda at 1999, which was from the California region. And also we're considering about the damage index and limit state from the ATC 20 technical reports at 1989. After we considering about the fin element model, input ground motions, and damage index, now we're considering about the machine learning method. So totally we're using 8 machine learning methods, and now at the chapter 4 we're considering about the result and discussions from this chapter. The next chapter is about the seismic fragility analysis considering Alcalá-Silca reaction model. So the target structure is the containment building of Korean nuclear power plant, and the used analysis software is same with the last chapter. And for the configuration of the model, we considering multi-layer shell element in this chapter. For the input ground motions, now we conduct the spectral matchings, and the target response spectrum is the NUREX CR0098 spectrum. So in the figure, you can see the time histories are well met with the target response spectrum in this study. Now I'd like to give you a brief introduction about the Alcalá-Silca reaction. So actually, the Alcalá-Silca reaction is the reaction between siliceous aggregate and the alkaline contents in the cement. So it will make the gel which absorb the water, and this water imbibition will result in expansion and micro cracks in the concrete, which means the material properties of concrete will be decreased due to expansion and micro cracks of the Alcalá-Silca reaction. There are many constitutive models for this reaction, but in this study we just considering about the Sauma and Perti model at 2006. So in this model, the strain due to the Alcalá-Silca reaction is defined as function of time, temperature, humidity, stress state, and the activation energy. After we choosing the model, now we try to validate the model with the experimental studies from the other researchers. So first one is about the cube specimen from the Gautam at 2016. So we successfully calibrate the model parameters as it summarized in this slide. The analysis result with the report for the Seabrook plant, and as you can see, the expected strain from the analysis model is a little bit different with the reported value. However, the level is very similar, so we try to using this model for the seismic fragility analysis. So the next chapter is about the result and discussions from each research object. So from the machine learning results, we consider the 3 parameters: accuracy, precision, and recall parameters. Thereafter, we try to judge which learning methods are the best when you're considering about the rank in each parameters. And as you can see, the random forest method is one of the best methods for the estimation on the seismic response. Next is about the analysis result for the ASR degradation model. So from the seismic fragility analysis, we can check that the median capacity of the containment structure is decreased about 20% when we consider about the alpha-silica reaction model. So finally, we're talking about the conclusion. So among the 8 considered machine learning models, none could achieve the highest values for all parameters, but in overall, the random forest model is suggested for use in predicting the damage states of steel moment frames in this study. From the ASR analysis for the containment, shows strain lower than 0.015% in both hoop and meridianal directions, which means it is similar with the reported value for the containment structure in Seabrook plant. And for the median capacity, it decreases about 12% when the effects of alpha-silica reaction is considered as change in material properties. So this is the end of presentation, and I will thank you for all the listeners and the participants in our BTS team.